Hello. This is about an electronic assembly and test system model 1. I'm going to state the problem first. In this problem you can see there's a system and in this system I'm going to explain the whole question on this picture first. On this picture you're going to see that there are arrivals of two different parts, part A and part B, and they arrive with respect to part A arrives with respect to inter-arrival time exponential 5 minutes, I guess, and part B is inter-arrival times exponential 30 minutes. So every 30 minutes there's there's a part B coming in. In part B, the parts are going to come in batches of 4. On the other hand, in part A, parts are going to come one at a time because there's no other note here. Then, part A is processed in this area and part B is processed in this area. The process name is preparation. The delay, the time it takes for the preparation of part A is with respect to the distribution triangular 148. And here I'm going to make it a little bit bigger for you. It's much better this way. And part B preparation area, it's going to take the distribution is triangle 3, 5, 10. You can read it as like minimum 3 minutes it's gonna take for this preparation for part B. Maximum time it's gonna take 10 minutes, and on the average it's gonna be 5 minutes. After part A preps and part B preps are done, they are going to be going to the sealer. There is a machine here which is going to seal the parts. Part A parts are going to be sealed with respect to the distribution triangular distribution 1, 3, 4, and part B parts are going to be sealed here in the sealer with respect to the Weibull distribution 2.5, 5.3. This 2.5 and 5.3 has meaning, of course, they have meanings. And then afterwards there's a choice that's some of these items, after they are being sealed, they are tested, and 9% of them will not pass the test. 91% of them, they are going to pass the test and they are going to be shipped because they are all good. But 9% of them, they don't pass the test. What do? Is they send it to the rework area. At the rework area, they are going to be reworked, and the delay time is exponential 45 minutes. So it's going to take on the average 45 minutes with respect to the exponential distribution. After the rework area, still 20%, there's a test, there's another test, 20% of them fail the test and 80% of them pass the test. The ones that pass the test, they are going to be salvaged and shipped. 20% of them are going to go to scrapped. And that's the problem that we are going to work on. You can see I highlighted some of the facts. Here you can find it in the question too. For example, I highlighted batch of 4 units that they are coming in, and there's this I'm supposed to also highlight this part too, part B exponentially with a mean of 30 minutes. It's the time between arrivals. Okay, time between arrivals of successive batches of part B. Okay. Similarly for part A, the information is given, and this part is about the sealer information, and there's this part saying that 91% of them pass the test, and then 9% of them are sent to the rework area, and 80% of them after the rework area they pass, and 20% of them they go to the scrap. And the delay type is 45 minutes at the rework area. That's what it says. And then the question is, we want to collect statistics in each area which means in a preparation area, sealer area, and a rework area. So we have actually two prep areas, part A and part B, one sealer area, and then one rework area. So we have in total 4 processes. And then we are interested in the statistics, of course. So we are going to collect the statistics in each area on resource utilization, how much of the resource utilized, and what's the number in queue in each area, and time in queue, waiting time, etc., and the cycle time, which is the same as total time in the system. Depending on the parts that are shipped parts, salvaged parts, and scrap parts. What does it mean, the cycle time again? So the items are coming, they arrive, and the time is going to start after they arrive to the system, and then we are going to keep the time, track the time till they leave the system, either as shipped or as salvaged parts or scrap parts. So this is the cycle time that we are interested in. For the cycle time, we are going to use the record module. And we are going to, it says, initially run the simulation for 4 consecutive 8-hour shifts, which is the same as 1920 minutes. So here there are 8-hour shifts at this in this work area. So 4 times 8, 32 hours actually in total that we are going to run the simulation.